Hi there, in this video I'm going to machine the flywheels for the Jerry Howell Farm Boy in this engine. Now the flywheel castings I got off eBay in the UK, and the seller is called Pedal56, and he was recommended by a couple of people that follow me, so that's very much appreciated. Now if you go onto eBay and search for Pedal56, it probably won't appear. So you've got to do some other types of searches like model engineering flywheels for steam engines or something like that, and eventually you'll find him. Now these are very close to specification for the Farm Boy, and the only sort of major difference I suppose is the hub on the Farm Boy sticks out slightly, and obviously they don't stick out on these castings. So my plan is, what I've done is I've made these pieces out of mild steel, and the idea will be to cut a recess in here and then stick these in with Loctite 638 and then machine them to spec. So that's the plan. Well, I had been hoping to use this back plate to hold the flywheel, but unfortunately the holes in the back plate just don't line up. So I've made this adapter plate out of aluminium, and I've attached it obviously to the back plate. It's running very true, and the idea will be to fix it using some kind of bolting mechanism there, and that will allow me to machine it. Pretty close. It's about 6 thou out, but I think that'll be okay. I'm just checking the inside rim here. Within about 15 thou, but I think that'll be okay. So I've set the carriage stop, so I can't go beyond that. So the tool will just pass the edge of the flywheel, and making sure I've got clearance on these screw heads, which I have. So I'll turn at the slowest speed in about sort of 5 thou increments, I think, initially. See how we go. So this is just running at 100 RPM, and I'm just using the manual carriage feed. Well, this is going to take a while, but I think it's just a matter of being patient. So I'll get back to you a bit later on. So I've just put a new tip on, and I'm running on fine feed now. Well, that's achieved a really nice finish. happy with that. Well, the drawing says that the width of this flywheel should be 0.8 of an inch, and it's already 0.79, so I'm just going to have to sort of lightly skim it and just get a finish on it. It's looking pretty good. I ended up taking 35 thou off that. Really nice casting. It's all getting a bit tight in here, but I'll try and tidy up this hub. You need to avoid touching the bolts that are holding the workpiece. So I think my priority now is to drill and ream this to 3/8 of an inch. So this is a 23/64 drill bit, and I've already centre drilled. So now I need to create the recess to hold that. Well, this seems to have turned out okay. So what I'll do is I'll Loctite that in place, leave it for a while, and then I'll drill and ream to 3/8 of an inch again. But I'll do that bit off camera. Well, that seems to have turned out pretty well. Now, I've not been able to machine this cam off in here, but I'll probably do that on the mill. And I've not machined any of that, and I'll do that on the mill as well. So all I need to do on the lathe is to switch it round and mill the opposite sides on these edges. So again, I'll just run this at the slowest speed. Well, that's pretty good for a first pass. So I'll just take another 1/10 thou off, and I think that'll be good enough. And then I'll do the boss, just tidy that up, but I'll do that off camera. Now what I did off camera on the lathe is I reduced this inner rim down by about 63 thou from the outer rim, and I thought before I put it on the rotary table on the mill I'd broach this keyway. It's 1/8 of an inch keyway, and this is the first time I've broached anything, so it should be fun. And I decided to broach it from this side because that's where the mild steel is, and if I did it from the other side it might pop that out. Maybe, I don't know. But it seems to be the safest side. Needs a bit of pressure. Just to give you an idea of the setup. It's my ton 2 press. Blimey. It's a bit tight. I'm going to have to move the camera, but I'll show you afterwards. Oh. Oh. Oh, my neck. Well, that's the first pass, so I need to put a little spacer thing in the back and do it again, but I'll do that off camera. Well, that worked out okay. Happy with that. Okay, so I centred the rotary table on the mill, and then I put the flywheel on the rotary table, and to get that centre I used the reamer that I used before, and it's pretty much spot on. If you look at it with this coax indicator, it's a couple of increments out, but I don't think I can get it any closer than that. I also used an edge finder to, you know, see how close these edges were, and to me visually they look spot on. So my plan here is to use this 3/8 of an inch end mill, ball nose end mill, just to clean this edge up here. It is a bit wavy, so I think if I leave it as it is, it won't look right when the machine's running. So I think it's worth a try. So let's see how we get on. Not sure about this. I think I'd be better off just using a plain end mill to do the centre bit, and then a smaller ball nose for the edges maybe. I think I'll try that. Oh, I'm getting there slowly. So I'll carry on. I'll probably go to a depth of, I don't know, based on this outside edge, probably I'll go to maybe 100 thou. I'll do that off camera. So for balance, there's a need to cut a recess in here with a ball nose end mill. It's a 60-degree arc, which is opposite the keyway, and it needs to go to a depth of about 135 thou. Well, that's turned out pretty good so far. I've left a little bit of meat on the hub, and I need to put it back on the rotary table and do similar machining on this side, but I'll do all that off camera. Once I've done that, then I need to drill and tap 3 holes and put a taper on it. So now what I need to do is to drill the bolt circle on the hub, and the plan says that you need to drill with a number 43 drill bit, 1/2 inch deep, and tap to 4x40, and the bolt circle is 0.66 of an inch in diameter. Now there's a number of ways of doing this, and for those who haven't got one of these intelligent DROs, you can use an app on your phone called FS Wizard, and you just type in the bolt circle diameter 0.66, number of holes 3, start angle 30. Now the start angle 30 is this angle here. So I know that there's 3 holes, 3 divided into 360 is 120. So I know that this angle here is 30 degrees. So you type in 30. The X and Y origin is 0, that's the centre point, and it comes up with that as an answer. And that's it on the phone. Really good little app on the phone is this. It's got loads of functions on it. Now another approach is if you've got a DRO that's got a bolt circle function on it, you can type in the parameters. Now the example in my book that came with the DRO is pretty useless really, because it only gives an example of a hole starting at the top. So the starting angle of 0. But anyway, there's a couple of ways of doing it on my DRO. Now option 1 is you put in a diameter of 0.66, you put in a start angle of 30, and you put an end angle in of 390. So that's 360 plus 30. And you say the number of holes is 4. So the way this will work is it will, I don't know which way around it goes, but it probably goes that one, and that one. So your start angle is 30, and then basically you're saying you're going to end at that point. So to end at that point you need 4 holes. The other option is to put in these parameters, so your start angle of 30, your end angle of 270. So that's your 30 degrees plus 240, so you got 120 there and 120 there, and the number of holes is 3. And both of these options produce exactly the same result. So on my DRO, I go for the bolt circle option. Comes with PCD XY, yes, it's that plane I'm looking at. So just type enter or press enter. Centre position is 0s, enter. The diameter is 0.66, enter. My starting angle is 30. My end angle is 390 because I'm going for the 4 hole option. Number of holes 4. And it gives me the position of the first hole to go for. So I just need to move the table to that position. Lock it. And lock it. So all I need to do is to centre drill, drill and tap 4x40, and then once I've done that I can move on to my next option, or my next hole. So I press that, this gives me hole number 2, which is on the y-axis it's the same position, and the x-axis needs to be moved to the other side. So that's my second hole to be drilled and tapped, and my third hole, this goes to 0 I think, and if you look at that there, you can see that the third hole is right at the bottom there. So I'll do the drilling and tapping off camera. Well, that was pretty straightforward. So the last operation is to cut a 6-degree taper on the inside of that. So I'm going to cut the taper on the lathe, and it's pretty much on centre. This gauge holder is fantastic. It's a Mitutoyo one, and you just have one screw adjustment, Highly recommend that. Saves a lot of hassle. Well, I've adjusted the compound slide to around about 6 degrees, and to check it, I thought what I'd do is just put a bar in here and touch the tool on the edge of the bar, and then what I'm going to do is I'm going to wind the compound slide back until I can fit in this slip gauge. I've done this already, and I can get this slip gauge in once it's moved back by 24.8 millimeters, which equals 0.9764 of an inch. So I can then work out what the angle is using sine, and it comes in at 5.93 of a degree, so I'm happy with that. So I need to cut this taper until the outside diameter is 0.55 of an inch. Well, this little engine is coming close to completion, and there's only 2 items I think now outstanding. Well, 3 actually, because I need to make another one of these. But the other 2 are the fuel tank and the ignition. So I'm getting very, very close. And this flywheel's turned out really nice. The castings, quality of the castings, fantastic. So I'm really happy with that. Could do with a bit more of a buffing, but I can do that off camera, and obviously I'll make the other one off camera as well. But I hope you like the results so far, and I hope to see you later.